So today I'm going to be discussing Charles's Law. First off, what is it? So Charles's Law is the concept that the volume of a given gas is directly proportional to its Kelvin temperature and constant pressure. This means that as the volume increases, the temperature does as well while the pressure remains constant. To put this in an equation form, it would look something like this, and if you wanted to demonstrate it on a graph, it would look like this. The temperature being the x-axis and the volume on the y-axis, and as you can see, both of them are increasing at a steady rate because they are directly proportional. So now that we understand the logistics behind this law, let's move on to some calculations that can be made using this. On page 425 of your textbook, practice problems 6 and 7 both deal with Charles's Law. Let's try to incorporate the knowledge we now have of this law into solving these problems. So problem number 6 is asking for the temperature, and it states a gas at 89 degrees Celsius occupies a volume of 0.67 liters. At what Celsius temperature will the volume increase to 1.12 liters? Okay, so the first thing you want to do is identify the variables in the unknown. So using the information that it gives you, you get that the volume 1 is equal to 0.67 liters. The temperature 1, which is 89 degrees Celsius that it gives you, needs to be converted into kelvins because whenever you're using Charles's Law, the temperature has to be in kelvins. So you add 273 to that and get 362 kelvins for the first temperature. And then volume 2 would be 1.12 liters, and temperature 2 is what we're solving for. So to rearrange this equation for this problem, you would do T2 is equal to T1 times V2 all over V1. And plugging in the variables we use, we would get 362 kelvins times 1.12 liters all over 0.67 liters. And if you calculated that out, you would get 605 kelvins. You may think you are done. Unfortunately, you are not because they gave you this in Celsius, so you need to convert it back. So all you have to do is just subtract 273, getting a final answer of 330 degrees Celsius. So let's move on to practice problem number 7, which is now asking for the volume. So number 7 states that the Celsius temperature of a 3-liter sample of gas is lowered from 80 degrees to 30 degrees Celsius. What will be the resulting volume of the gas? So like the problem before, let's start off by identifying the variables and the unknown. So the first temperature is 80 degrees Celsius, which you need to convert into kelvins, and you should end up with 353 kelvins. The first volume is 3 liters. The second temperature, 30 degrees Celsius, adding on 273 to get 303 kelvins. And the second volume is what we're solving for. So to rearrange from Charles's initial law equation, you would get V2 is equal to V1 times T2 all over T1. And plugging in the variables we decided on, you do 3.00 liters times 303 kelvins all over 353 kelvins. Calculating that out, you would get a final answer of 2.58 liters. So that is Charles's Law and how to calculate with it, and I hope this helps.